It's pretty bad. You and Marco's like Dumb and Dumber. Oh, you gotta start laughing. Okay, so start with what do you say?
No, like I know when you're ready. You're like, okay, let's just go.
Yeah, shut the hell up. Get to work. Uh, let's start with this one. Let's see if you guys can do it on your own first.
Move your thing.
So air is being pumped in to a spherical broom, like we talked about last year. There's no such a thing as spherical broom. But yeah, let's assume they are at a rate of 4.5 cubic feet per minute. I want to find the rate of change of the radius is 2 feet. Okay, so that's A. For B, I want to find out how fast how fast.
Wait. So find rated. Wait, what do you mean by rated?
How volume increases by feet?
You find rated radius is 2 feet.
Yeah, radius is 2 feet.
Oh my god.
Okay, air is being pumped into a spherical broom at a rate of 4.5 cubic feet. Oh, cubic feet is the wrong unit. Dumbass. Find the rate of change of radius is r is equal to 2 feet. And also find out how fast the surface area is changing when r equal to 2 feet. Starving. I miss Tunisia. Not Tunisia. Damn. No, I don't think it's right.
No, like she's not do Cal.
Oh yeah.
Like her presence is just weird, you know?
More girls.
Next year.
Wait, Yulia, you want to join a girls group? Maybe. You can come in. Emil, she's dumping you. Sorry.
Sure, that's why next year.
I can't do
No. You're gonna be on your island, Marcos. You are infectious disease. You are infectious disease. You get people dumber.
Make him smarter, but dumber. That's it. Inversely proportional. Yeah.
Inverse square proportional. You have a radius, so it's a square.
Oh, your handwriting is as bad as his. Oh my god.
No, it's not.
Like, I can't read that, and then I can't read this. Like,
No,
what
you
am I
have to find the rate of change for radius, and the radius is equal to 2 feet. Okay. Then for B is how fast the surface area changes when the radius is equal to 2 feet.
Have you learned this in Ukraine? Don't remember. So the first goal of this is to did most of you guys finish or no? Matthew's like, I finished like 5 minutes ago. Why are you guys
Radius
so slow?
is radius. He's gonna like follow me down.
Okay, so establish relationship. So what would be a relationship here? What will be the relationship here? What's the relationship that? What will be the formula for the relationship here? Related rate, it must have a relationship.
Doing the volume?
Volume of what? Sphere. What is the volume of sphere? 4/3 pi r cubed. Devin, you better change this form before I become racist. Great changing form. If I become racist, I won't change your grade anymore. I'm not yet racist.
You gotta stop.
He's getting there slowly.
Getting there slowly, gradually.
We need Deborah. Deborah will keep you in check. Man.
That's true.
Deborah's the only one that keeps you in check.
I don't miss Deborah. Kelly remind me of
What
her.
about Martine? What about Martine? Come on, Martine. You don't miss Martine?
All right. So first of all, establish a relationship. The relationship has to help you the problem, and then you have to figure out what do you know. So what's a 4.5? Shut the hell up, David. Thank you. So 4.5 feet per minute. What does that equal to?
Equals dB over dt.
That's how fast the volume is changing. So you gotta convert that sentence into the understanding, because you are pumping in the air. Now, airs can also be pumping out as well. They can be negative 4.5 or they can be positive 4.5. You gotta be careful of the words. Sometimes people don't read, which is, I know most of you guys don't read, but you gotta read the stuff. Are they pumping in or are they pumping out? Is the ladder sliding down or you pushing the ladder up? There's all different things, situation can happen. Is that okay? So now dB/dt is means this how fast the volume is changing. Because the unit is a cube, you can just see this is a cube. That's also told you the volume is changing per minute. Is that okay? Now, what we need to try to find the rate of change of radius. What we're looking for. dRdt is the unknown, right? Usually I start with this element. I start with the relationship. I start with translate the math that they give it to me into math equations, which is dV/dt equal to 4.5, and also find out what is the unknown. And after that, it's the easy part. Just take a derivative with respect to time. So now I'm going to take derivative respect to time. So that means I'm going to do d to the dt of volume equal to 4/3 pi r cubed. So that's going to be what? dV/dt, which is something we know, and that's going to be 4 pi r squared dr/dt. What do we know about dV/dt? With 4.5, right? That's equal to 4 pi, and r is what? 2 squared. Because the only thing that we don't know is dr/dt. Can we solve for it? Well, this one is 9/2, and that's equal to what? 16 pi. Yeah, that's right. dr/dt. And then you can get 9/32 pi. And that's how fast the dr/dt is. Now that is the first part, right? What is the second part? The second part says, what is the surface area changing? So as air is expanding inside the balloon, it's getting bigger. Not only volume is changing, the surface area is also changing as well. So then you have to figure out what is the relationship for the surface area. So what is the surface area of a sphere? 4 pi r squared. Good. So area is equal to 4 pi r squared. And this time they want a dA dt is equal to question mark. That's the unknown. So I'm going to take d to the dt here. So usually I call it dsa dt, which is dsa dt, which is surface area, equal to a pi r dr dt. Which is dr dt, you already know. What is dr dt? 9 over 32 pi. So pi and pi cancel out. This is 4. So that's equal to, wait, 4 over 2. Is that going to be 9 over 2, right? Yeah, 9 over 2. 9 over 2. Now, pay attention to the unit. The unit is going to be feet square per minutes. Because the unit is going to matching of your dimension. Your dimension is going to be feet square per minutes. Did I really write that small? Why don't you wear glasses? And change your because I don't know. Got it? Okay, so let's give you a question. What kind of question I should give it to you? You know what? I come up once. Okay, let me see. Ooh, that's a BC test. I don't like this one. I don't like this one. Oh, I like this one. Okay, let's go with number 1. Should be easy. That doesn't help either. Oh, this one's interesting. Thomas, you can move it to the front. Your OC. David and probably sit over there. It's better for them, right? Can they see? Can you see?
Well, yeah.
No, now you're gonna block Kelly. So sit over there. No, sit over there, next to Charlie. Can you see? Okay, now you can see. That's fine. Yulia, can you see? Huh? Oh, you cannot see either?
No, I mean, I'm fine.
I'm gonna enjoy my sandwich. I'm looking at Luke. Not you. Oh. Just the equation, yeah, points of phone. Oh, look, shut up. Get away. What is going on there? It's only one question. I swear. Maybe we should use Marco's example, how fast he can expand his dominance,
Change.
the rate of change. His effectiveness is three-dimensional. It might affect somebody upstairs too. Matthew, you got an answer?
Yeah.
Y'all too slow. Devin, what are you doing? What are you doing? What? It's not working. How much you're done? Charlie, are you done? You are done? Better? Charlie? Man? You no? Steven? What? Oh, okay. If there's a dumber and dumber, who's gonna be a dumber between you two? You are?
Actually, it varies.
It varies.
Depending on.
I don't know. I didn't do it. All right. So I never do a problem. The radius of a increase. So what is constant rate of 0.4? What's that translate to math? DRDT. is equal to sorry, I'm not right on here. DRDT is equal to 0.4 meter per second. Okay, it's per second. Okay. Then what's the rate of increase of area of a circle at instant when circumference? So is that area implied surface area? Oh, that's a two. Oh, yeah. Duh. I'm on correct. So area equal to pi r squared. So that will be a relationship. And they have a circumference is equal to 60 pi. So circumference is equal to what? 2 pi r. And then 30 pi equal to 2 pi r. What? 30 pi equal to 2 pi r, right? R is equal to what? 15?
No, C equals 60, so 60 pi equals 2 pi r. So R equals 30.
Oh, this one's 60.
Yeah.
Oh, sorry, my fault. I copied down wrong. So that is the R is equal to 30.
Yes.
Now you can take a derivative respect to time now. And that's di dt is equal to 2 pi r dr dt. Do we know r?
Yes.
And do we know dr dt? What is that? 0 is 2/5. 2/5. Okay, so that is going to be 6. So 24 pi.
Yes.
Is the answer choice in there?
It's the, wait, yeah.
Meter second. Is that okay? My God, it's affecting Devin. Devin's not like that before, I swear.
No.
Marcos, I might have to lock you out of the classroom.
It's just nature. You can't stop nature.
Okay. Cylindrical are a little bit different. There is a two relationship inside a cylindrical. Do you guys remember what kind of cylindrical? Cylindrical is cylinder. Oh, not mine.
You mean cone?
I was thinking about comb.
That's a ladder.
Hey, we're gonna do ladder. I'm gonna help you with relationship. Here, the relationship is
Can you zoom in? Thank you. Okay, thank you. That's actually so much better. Yeah, that's like so much better. I think we just set that up.
How are you supposed to read?
Matthew. You're gonna help out Charlie and Brendan.
chemistry, if the ladder is moving away from the building at a constant rate of 2 feet per minute, then would it still be 2 feet per minute at 9 feet from the building?
Yeah, why isn't, why don't we try to find the, like, the top of the ladder?
Everybody can share.
It's asking for the base, like it gives us.
Right to the base. Constant.
It's just the base slides away at 2
It's
feet per
it's
minute.
already saying the constant rate.
And then, well, am I tripping?
Isn't it still 2?
Especially bleaching.
Yeah.
Yeah, that's a bad question.
Oh my god, I'm rolling.
Oh,
Can you go another question? I like down 10.
Another rather question?
Yeah.
Okay, fine.
Really why?
Okay, this is another question. This is better. That's from textbook.
Oh, you need to move.
Is that better? There's 3-part questions here. Now, that's a tall ladder, yeah. Now, Yulia, the ladder is 25 feet long. That doesn't change. That will help you. So same thing, some people never take the calculus, Charlie and Brenner. The ladder is 25 feet long, and that part will never change. It's a constant. One thing nice about constant is when you take a derivative, it's gonna go away. The second part and third part of the question, if you know how to do it, keep on continuous going. Yulia, what kind of relationship is this? Could be anything. It's a very easy one. It's in geometry. No? Give it a try.
I'm trying to think. Trying to think what's ladder.
A ladder?
Yeah.
Oh. A ladder looks like this.
I think person should have said that.
Okay, sorry.
No, you don't know what
A ladder.
you know?
Oh.
Mr. Yang.
What? A ladder looks like this.
Oh, okay, I know, yeah. It's what
And it's
I was thinking
it's
about.
on the wall.
Yeah, okay, yeah.
25. And you're pulling away from here.
Well, yeah, the length stays.
Yeah.
You can't change
Yeah.
that.
I think it's just.
Just like relationship, ladder and height.
Yeah.
Almost. Not it. That'll be area. It'll be area inside the thing.
So they didn't.
Huh?
Area does change.
The area does change. But we are not looking for area. They are looking. They are wondering how fast the ladder is sliding down. So they are wondering this part, how fast it go down. We know this way is 2 feet per second.
I remember last year there's something about like if it's telling you it's going down, it's not gonna be negative. Like if it's already telling you the problem, because I remember that was
Yeah, I just don't remember teaching this.
like see if it's sliding away, that's gonna be negative. If the value going down, it's already telling you it's going down.
Okay, so for those of you who are new, this is actually just x squared plus y squared is equal to 25. So this is x, this is x, this is y. It's called Pythagorean identity. You understand? If I were to take a derivative with respect to time, and we also have a dx dt is equal to 2 feet per second, right? It's pulling away. How fast are they coming down? Well, we need to take a derivative with respect to time. So, and they say, how much do they pull away? It's 7 feet, right? 7 feet at first, right?
Oh,
According to the question, they say the base is 7 feet. So we're gonna say this is 7 temporary, but it's changing. So we cannot say it's always 7. So then you have to take a derivative with respect to time. It'd be 2x dx dt plus 2y dy dt is equal to 0. You guys remember this? Start coming back. 2x. So this one is gonna be 7. dx dt is gonna be 2 plus 2y dy dt. Do I have a y here?
well you can do 24.
You can find out this is a Pythagorean triplet. This is 24. So it'd be 2, 7, 2 plus 2 times what? 24 dy dt, right? And that's equal to 0. So that's going to give you, move to the other side. So it's going to be 28, I think, over 48 equal to dy dt. And it's negative. dy dt is negative. But if the question says sliding down, then you can say it's positive. But depends on what the question says. I don't know what the question says. The question says how fast the top letter is moving down. So at this case, I will simplify this though. -7 over 12 feet per second. You can say it's moving down at 7 over 12 feet per second. So some people always misunderstand. If you're moving away 2 feet per second, it's the ladder is going to go down at 2 feet per second. That's not true. If you have some logical sense, right? If I pull away, what? Which is some of you guys don't. So if I pull away right here, like in this part, just imagine if I have a ladder, right? Just say imagine I have this. Like if I'm pulling away, if I pull in sense speed, this gonna be, they only move down by a little bit. But if I all the way here, if I move just 1 inch, it's gonna go down a lot more. So it's different if I pull away and I'm going down. They are different speed the whole time. If I have pulling more toward like this part, if I pull a little bit, I'm gonna go down a lot faster. So when the ladder is more away, this is gonna go down a lot faster. At one point, it's gonna drop really fast.
No.
But when in here, if I pull a little bit here, it's only going down 1 centimeter. If I pull 2 centimeter here, so you have to understand that relationship between the two. So, yeah. So that's the first question. Yulia, does that make sense? And then make sure the constant is gonna always help you here. The constant's always gonna help you here. So the constant, if you take a derivative, it's gonna go to 0. That's a nice thing. The second question is a little bit different. I'm gonna go back to the question. You can take a picture of this question. The second part of the question is, consider a triangle formed by the side of the house and the ground. Find the rate of change of area of a triangle is changing when the base ladder is 7 feet. So now relationship have changed. What am I paying attention right here? The area. Okay, so let's look at the area. The area of this part right here, this is what I'm caring about. But area is equal to 1/2 base times height. Does that make sense? And then can I say area equal to 1/2 x times y? Can I take a derivative here? It's going to be dA dt is equal to 1/2. Now this is actually the first time related rate that has what? Product rule. Do you see that? X times y. So it'll be dx dt times y plus x dy dt. Which is okay. Dx dt is what? 2. What happened to y? I think it's 24, if I remember correctly.
Yeah.
X is what?
-7.
7, and dy dt is -7/12, right? And I don't bother to solve that, but I know you guys know how to do that. Minus 47/12. Yeah, you do the math. 49.
See, that's why you need my multiplication chart up. You don't know how to do multiplication.
Two.
You made that last year?
Yeah.
You should make it up for all the algebra 2 kids. Huh? Sure. You can take a picture of that questions. Last one is the most difficult one. The last one is a relationship of angle. If you ever have an angle, let's say it's this angle, we want to see how fast the angle is changing. Do you guys remember that? Use what on the bottom? Constant on the bottom. Because constant on the bottom, when you take a derivative, it's going to be much better rather than constant on the top. So remember, this is an x, this is a y, and we want to find out this angle is. So I want to set up a relationship where the constant's on the bottom. So I hear what is constant in here? 25, right? Now which equation I'll be using? Do I use a x in 25 or do I use y in 25? Which one's better? Yx is better.
Because
It's giving. X is dx dt is giving, right? So x and 25, which trig function I'll be using? Okay, so the cosine of theta is equal to x over 25. Can I take a derivative of this? What's derivative of this? Negative sine theta times d theta dt equal to 1 over 25. Now, why did I choose the constant on the bottom? Because constant on the bottom is the easiest one to take a derivative. If you have 25 over t, that becomes more complex, and you don't want to deal with that. You want to deal with constants always on the bottom. So this is the ladder length because it's a constant. And I want to deal with constant on the bottom because all I got to do is write down dx dt. And then d theta dt is equal to 1 over 25. Dx dt is what? 2 times the other side is going to be 1 over sine theta, right? So it'll be 2 over 25 times something over hypotenuse, y over r, r over y. So it's going to be negative 25. Y is 24, I think. So that is going to be negative 112 radian per minute. I'm gonna write down sine of theta is 25. Oh, sorry, it's 24 over 25, right? 1 over sine is what? 25 over 24, which is, that's why I cancel out the 25, and that's negative 1 over 12. And those of you guys remember, how many degrees 1 radian? 57. Good. Wow. Very impressive. And divided by 12, that's roughly 4 point something. So it's about changing about negative 4 degrees per minute.
Negative 1 over 12. So that's it.
dx over dt.
1 over 12, right?
Because it's in the question. Also in the question. This is like 2 2.
Going too fast?
As long as you're recording the video.
It's supposed to be compliments.
Yeah, it's great.
The bottom equals closing, so it's a negative, the other one's open.